For our second and final example of section 7.3 day 3, we're going to do an application that I think is really pretty interesting, that you can tie this all into systems of equations. I hope you agree with me, but we're going to fit 3 points to a parabola that using a system of equations, and thinking about what it means to have a quadratic equation that is in the standard form ax squared plus bx plus c. We're going to make that fit exactly to these 3 points, and to do that we're going to need 3 equations, one equation for each point. So we're going to start by making an equation for each one of these points and plugging it in basically to our standard form of a quadratic. So I'm going to start with negative 1, 5. So negative 1, 5 xy, we're going to just plug that into what we see right here. Now keep in mind that f of x is y. I'm going to put that on the other side just to make the equation look like the ones that we've been using. But we're going to have a times negative 1, since that's the x, squared, plus b times negative 1, x again, plus c, and then we're going to make that equal to y, which in this case is 5. Now if that's our formula and we just simplify this a little bit, that means what we have here, negative 1 squared is just 1, so that's really, oops, I'm going to do an arrow here instead. That is really a minus b, because that's negative 1 times b, plus c equals 5. So there is our first equation that we're going to use in a system. We do the same thing for the others. A times x squared, so that's 2 squared in this case, plus b times 2 plus c equals y, which is negative 1. We simplify that and it looks like we have 4a plus 2b plus c equals negative 1. So there's equation number 2. And then we've got 1 left. A times 3 times x squared plus b times x plus c equals our y value of 13, giving us a third and final equation of 9a plus 3b plus c equals 13. So we've got 3 equations. We want to solve for a, b, and c. 3 equations, 3 variables. That is how we've been working with things. That's a system of 3 equations, 3 variables, as you see right there. So we're going to solve that system now. That's our goal next, is to solve that system, and then hopefully at the end we can figure out the exact standard form equation for this quadratic and include those different points. Now, what we've been doing with systems of equations is we've actually been converting those. Now, the one that we just did a little while ago was a matrix equation. We're going to do that again here just to use that method one more time. We could, again, use any method we wanted to. We could use row operations, we could use matrices, any of that's available. We're going to use matrix equations here. So I'm going to start by making this into a matrix equation, and I'm going to have my coefficient matrix. My variable in this case is going to be ABC, and then the right hand side is B again. So using my calculator, I could find the inverse matrix, and then I could multiply those two together. I just want to verify that with you so that you can see that I did this on my calculator. I've got the matrices plugged in here already. Here's my first one. That is the coefficient matrix, like you see right there. Then I have B, which, as you can see, is the same thing as B over here. All right, so I do, again, the key in this is A inverse times b. And what comes out is 4, negative 6, negative 5. That is right here. So what that means is that our variable matrix is 4, negative 6, negative 5. That's what A, B, and C are equal to. Well, A, B, and C, those are the A, B, and C from our standard form of a quadratic, and that means that those 3 points, the information we've gotten from those 3 points, gives us this as a quadratic equation that exactly fits all 3 of those points. Now, if you want to be sure about that, you can plug them in one by one, see if they work, or you can graph them. I'm going to take a second here and graph this equation. So we've got 4x squared minus 6x minus 5, and I'm going to use my standard window, I think. And so there is what my graph looks like. And I want to figure out, okay, are those points actually in there? So maybe I start tracing this, and I want to find out if negative 1, 5 is it. So I'm on trace. I'm just going to punch in negative 5, hit enter, and whoops, I meant to hit negative 1. So I'm going to trace it again. Oops, go back to the graph, trace it. Okay, I meant to punch in negative 1, and there we go, negative 1, 5 is one of them. I keep tracing it. Maybe now I punch in 2 for x, and there's my point, 2, negative 1, and then finally 3. Just punch in 3. It's off the grid somewhere, but 3, 13 is another point. So as you can see, all 3 of those points fit exactly on this equation, and so that's kind of an interesting way that I think you can use systems of equations to relate to other things that we've done in the past.